Introduction, section 4.3.2, the deceptive parallel. Okay, in the last video, we talked about the fact that we could rewrite the total charge density as the sum of the free charges and the bound charges, and that allowed us to, in the end, define an electric displacement vector, D, which was related to the electric field and the polarization. And we got, in the end, we got something that looked like Gauss's law that said that if I integrate all of the vector D, leaving a surface, that is equal to the total free charge that I've enclosed with that surface. And we did Gauss's law on the cylindrical symmetry and found the electric displacement vector. Now, in that instance, D and E were essentially the same. I mean, the way we treated it, rather. We knew that they weren't exactly the same, but that you can treat the electric displacement vector and the electric field as the same thing. Okay? But that's not always true. Okay, and Griffiths warns us to be careful about this. So let's go ahead and rewrite. Well, let's take this first line here, and let's take the curl of both sides. Okay, so I can take the curl of D, and that's going to be equal to the curl. I'll distribute that curl through of my electric field plus the curl of my polarization. Now this is always equal to 0. The curl of our electric field is always equal to 0. But the polarization, well, that depends on the geometry of the problem and the circumstances in which we're solving the problem. So there's no reason for the polarization to be curlless just by default. It might be true, but it may not. Okay, so because we can't say that the polarization is always curlless, that means that we can't say that the electric displacement is always curlless. And if the electric displacement is not always curlless, then we can't write down something that looks like Coulomb's law for the electric displacement vector. Okay, so if symmetry permits, you can do something like Gauss's law. That must mean, in that case, that if symmetry permits, then your curl is 0. But if symmetry is not allowing you to use Gauss's law, then you can't solve immediately for D using this formalism here. Okay. So we have another tool in our toolbox, but we have to be careful about how we use that tool.